Part B of this question is still on binomial hypothesis tests, but there's a little bit less to do now. So it's still about Suzanne, but she's switched now to squash and she's played 20 matches, so her sample size has changed. Find the minimum number of matches she must win, for her to conclude at 10% significance level that the new racket has improved her performance. So some of the changes, N is now 20 when it was 10 before. We've got a significance level of 10%. And because it talks specifically about an improvement in performance, this is now a one-tailed test. But we do still have to bear in mind that original 0.5 probability from before. So we're now looking at a binomial distribution where she's playing 20 matches based on her previous average of winning 50% of her matches. So we've got a binomial distribution with n equals 20 and p equals 0.5. Now what's the question here? It's to find the minimum number of matches she must win. So what I've highlighted there in red is basically, in the context, a way of asking us to find the critical region for a one-tailed test at the 10% significance level. Find the minimum number of matches she must win to be significant. So we're looking for the one tail, the upper tail, critical region for this binomial distribution. So again, we'll look at the graph, we'll look at the table, and we'll figure that out. So here we've got a plot again of the binomial distribution, B20 0.5. Remember the mean, 20 multiplied by 0.5, that's 10. And once again, that's right in the center. It's the highest probability, so it's the mode. And nearby 9 and 11, and so on. We're doing a one-tailed test. We're looking for an improvement in her performance. So we're trying to find a tail up here in the graph of significantly high values. And now we don't care anymore at all about finding a lower tail because we're just doing a one-tailed test. And we've got our 10% significance level set for finding that tail. And we've also brought in the formula book. Or again, you could create your own binomial CD list on your calculator. And it doesn't matter that we can't see the top of this table because we're looking for the upper tail. So we're looking at the values down towards the end of this table here. So just like before, we'll write out a couple of them and see how the calculations work out. So I'm going to point at number 11, 12, 13. Let's have a quick look at those values. We're getting 75, 87, 94% approximately. Because we're looking for a 10% tail, it means we need 90% everywhere else. So for example, the probability that x is less than or equal to 12 is 0.8684. And if we think about the sort of complementary probability, the opposite as it were, the probability that x is greater than or equal to 13 is 1 minus that number above, so that will be 0.1316. And that's too big. That's too big for our significance level. So 12 is not the right line in the table to look at. So we'll move down and we'll check out the 13 line. And again, I'll erase my calculations so that we can update them to look at that new line. So in the table, we're now reading the line that tells us that the probability that x is less than or equal to 13 is 0.9423. And again, if we think about 1 minus, the probability then that x is greater than or equal to 14 is 1 minus that value, which is 0.0577. And that is now under 10%. So this is good for us. So x greater than or equal to 14 is our critical region. So in your exam answer, you would show those two probability calculations, and at the end, you would conclude that your critical region is x is greater than or equal to 14. Now let's read the question again. Find the minimum number of matches she must win for her to conclude that her performance has improved. Well, she's got to win greater than or equal to 14, so therefore the minimum that she can win to claim that she's improved is 14. And we finished. And it's important to note that this question didn't need a full hypothesis test. They only wanted to know the minimum number of matches to win, so we didn't have to write out all our hypotheses, H0, H1. There's no conclusion to write because we don't know actually how many she did win out of 20. It's purely about finding that critical region by looking in the tables.